So we're going to continue talking about logic today. And I want to start with statements and conditionals. So we've got a few vocab terms to take a look at. The first being statement. A statement is a sentence that is either true or false in terms of how we're going to take a look at them here. And we'll see down here something like a truth value, but we'll talk about that in a minute. The way that a statement is represented is you're typically going to see them represented as a P or a Q or an R or something like that, where you will be given P as representing some sort of statement. And well, again, we're going to get into that, but these are kind of the building blocks of what we're going to do. Truth value. If I'm saying something, asking what is the truth value of this statement, you're basically just saying whether it is true or false. Negation, that's not really any different than negating a number. If I'm negating a statement, I'm getting the opposite meaning and the opposite truth value of the original statement. So if my original truth value is true, I have a true statement. If I negate that statement, it will be false. Notation for this is this little squiggle and a P, or whatever your statement is. If I've got Q as my original statement, that's going to be my negation of it. And it is read as not P or not Q. So let's take a look at a couple different types of statements. The first being an open statement. A statement which contains a variable. Now the first one that they've got here is relatively familiar to us, or it should be, where I have a statement x plus 2 equals 8, the variable being x. We know that. That's how math has worked for a while for us. A little bit more unfamiliar would be the second. If I have the statement, it is my favorite color, the variable here is still a concept that we're familiar with. The variable is something that we can replace with something else. So in this case, the variable is going to be it, because I can put any color there in that statement to make different statements. I can say blue is my favorite color, red, orange, what have you. And then it says the truth value of an open statement depends on the value that replaces the variable. So we'll talk about that a little bit later. A closed statement is one which can be judged as true or false no matter what, there's no variables in it. So for example, they say Garfield is a cartoon character. I know that's true. There's no ambiguity there that I have to think about. The second statement there, a pentagon has exactly 4 sides. Again, I can say if that is true or false. In this case, it is false because a pentagon has 5 sides. So I'm going to say that statement is false. And then what we're going to spend a little bit more of our time on is these compound statements, where you have 2 or more statements connected in one sentence. We're going to look at ands, ors, if-thens, and if and only if. Those will make a little bit more sense once we actually get into it. But let's keep going with this kind of building block stuff. Before we said negation was basically saying not. Not P, not Q, not whatever, not the original statement. So it's usually formed by adding not to the original statement. And after something is negated, we said that the truth value changes. A true statement becomes false, and a false statement becomes true. So for example, if I'm taking this, 15 plus 20 equals 35, if I am negating that statement, in order to do that, I'm just saying 15 plus 20 does not equal 35. And if I look at the truth values of that, the first of my original statement, 15 plus 20 equals 35, that's true. After I negate it, though, and throw that does not in there, that is false. Not a true statement. So why don't you guys, when you get a second, do that one. Negate a dog is a cat. And see how you do on that. Next, we're going to look at something called the truth table. All the truth table is it kind of shows all your different possibilities of the truth value of a statement. So for example, if I have a statement P, anything I have can either be true or false. If I'm saying not P, we said that a not has the opposite truth value. So a true becomes a false, and a false becomes a true. We'll look at a few more complicated ones than that. Next on there, we've got a conjunction, or an and statement. It says it is formed by combining two statements using the word and. A conjunction is only true when both statements are true. So what does that actually mean? So it says combine the statements in each example and determine the truth value. Let me delete that so we can start from scratch. So if, for example, I'm taking number 1 and I'm going to make that into a conjunction, all I'm doing is I'm saying blue is a color, and that's my conjunction, 7 plus 3 equals 10. Now, in order to determine if that conjunction is true or false, I have to look at both of those statements. Blue is a color. That's true. 7 plus 3 equals 10. Also true. So if I've got true statements, I can say that whole thing is true. So then let me look at the next one. If I say 1 hour equals exactly 55 minutes and 1 minute equals exactly 60 seconds, making conjunction is just taking those statements and throwing an and in the middle of it. But then I want to look at my different truth values. 1 hour equals 55 minutes. That is false, not a true statement. And we know that. The next part says 1 minute equals exactly 60 seconds. That's true. But on the previous page, we just saw that if I have a conjunction and I'm putting those together with an and, I need both of those statements to be true in order for me to say that whole conjunction is true. So the whole conjunction is false. So I want you guys to do the same thing, try and get that one done. Once you're through with this. The next thing that is on there is a conjunction truth table. Now something I want you to take note of is this right here. That is my symbol for a conjunction. It looks like, I think an easy way to remember it is it looks like an A, or you can make it a little A, and it stands for and. So for example, over here, that says, if I'm going to read that out loud, it is P and Q. So let's look at a truth table for this. Like I said, truth table is basically just breaking down all my different possible cases of the truth value of statements. So if first I want to say, okay, if my P is true, there's a possibility that my Q is also true. That's one of my options. But there's also the possibility that P is true and Q is false. And then I'm done. I've covered all my bases with my P being true. But then also, what if P is false? Q could be true. Or both could be false. So going with what we said before, in order for a conjunction to be true, both pieces have to be true. The only one that's going to be true is the first one, my true and true. All the rest are going to be false. Because I need both of them to be true in order to say that the entire statement is true. If we look down here, a conjunction is a little bit different. Conjunction is not using an and, it's using an or. The method is the exact same, except we're putting an or instead of an and the way that I figure out the truth value is different, because if I have a disjunction or an or statement, it is true when one or both statements are true. So not both of them have to be true. So for example, I'm going to skip number 1 because it's a little bit of an easy case. If I look at number 2, I'm saying again, 1 hour equals exactly 55 minutes. We already said that is false. And the second one, if I'm writing this as a disjunction, I'm going to throw an or in between. The second one is true. So coming from this definition that I have right here, I have 1 false, 1 true, but I can say the disjunction is true because I have at least one thing that is true. So disjunctions are much easier to prove true than a conjunction because I just need one or the other to be true. So you're going to try 3 and 4, and we might actually, before you do that, let's take a look at a disjunction truth table. I'm going to start the exact same way. I'm going to say, okay, both can be true, or P can be true, Q false, and so on and so forth. In this case, it's pretty much the exact opposite of the other one. It is always true unless both things are false. That is the only time that that is going to be a false statement. So let's keep going. Something that I will take a look at really quick. We're not going to do too much with constructing truth tables, but I want you to be familiar with them. They're not too bad. So my end result that they want me to they want me to show the truth value of the different possible truth values of not P or, remember that's an or, not Q. So I'm going to start the exact same way with my different options. But then I want my little pieces in here so I can look at them. So my little pieces up here, I want not Q and I want not P. So my truth values for my not columns are the exact opposite of my original one. So like my not P, I'm just going to have the exact opposite of the truth values that are in the P column. Not Q, I'm going to have the exact same the opposite truth values of what's in my Q column. And then again, it's a disjunction, and when I have a disjunction, it is true unless both of my pieces are false. The only one that is the case is this one right here. So that's false, and the rest are going to be true. So let's flip the page. So I'm only going to go over some of this because the rest of this is actually in a separate video where another type of compound statement that we have is called a conditional. And what a conditional is it's an if-then. So if I have a statement P and a statement Q, I am reading it as P implies Q, or if P, then Q. That's what a conditional is. It's an if and then. And there's a couple different parts of it. Whatever part is following the word if, that is your hypothesis. And whatever is following your then is a conclusion. Now, they're not all... Some of the problems that we're going to see are going to ask us to turn something into a conditional statement, and we'll see a couple of those. But whatever part follows your if is your hypothesis, and whatever follows your then is your Q, or your conclusion. So all of these are going to be covered in the next video, but this is what I want to talk about right now. So for example, the example they gave us is if two angles are vertical angles, then they are congruent. This if two angles, that is my hypothesis. They are congruent, that is my conclusion. So that's going to be helpful to us to do all of this other stuff that we're going to do next. But for right now, let's take a look at these down here. For example, the first one said, if I study for the quiz, then I will earn a higher grade. My hypothesis is this right here. My conclusion is this right here. If I study, then I will earn a higher grade. You guys can try number 2, because that one's very similar. These are the ones that I was talking about. Sometimes they're going to ask you to take a statement and put it in to an if-then format, a conditional format. In this case, it says all dogs go to heaven. The way that I am going to put that into a conditional format is if we can say if an animal if an animal is a dog, then it will go to heaven. Or I could say, if you are a dog, you will go to heaven. Something like that. It's not, and these kind of like proofs, there's no one specific way that it has to be worded, as long as it kind of looks something like this. So you guys can try that with that one. All puppies are dogs. And then the rest of this is going to be covered in another video. So you will get to the rest of it a little bit later. Go through and finish those U tries that I pointed out in there, and then we'll go from there.